In this video, we are going to talk about the third stoichiometry problem. That is, when you are given mass of one of the species. For example, you are given mass of a reactant and you are asked to determine the mass of the product. So that type of stoichiometry problem, we call it mass to mass problem. So I will show you an example of how that problem is done. So suppose we have gasoline that burned, and during the burning we produce 24.8 grams of water. So what I want you to do is to determine the mass of gasoline used. In this case, we are assuming there is 100% conversion. You can see that you are given the molar mass here, the molar mass of octane, that is the molar mass of gasoline. And also take note that you are given the equation here. This reaction equation is going to help us determine the ratios that are reacting. So let us take note of that. But how do we work with this problem like this one? The first thing is to determine what is your given quantity. What are you given and what do you want to determine? So here we'll see that what we are given is 24.8 grams of water. This was produced. But what we want us to find is the mass of gasoline. That is the mass of octane. Now we know that when solving conversion factor problems, we start with a given quantity and then multiply those given quantity by the conversion factors. Also, we need to take note that in this case we are given the mass of the product, not mass of the reactant. So which means we will need to move backward. First we have mass of the product. We need to find the moles of the product. Once we get the moles of the product, that is water, that will help us to determine the moles of the reactant, that is the moles of octane. Once we get the moles of octane, that is going to help us determine the mass of octane that burned. So let's see, how are we moving with that? First, we get the mass of product. From the mass of product, we calculate the moles of product. From the moles of product, we calculate the moles of reactant. After getting the moles of reactant, we determine the mass of reactant. Based on this, we can see that we are dealing with three conversion factors. This is the first conversion here. This is the second conversion. So each arrow is representing a conversion factor. What does this mean? It means this problem will start with the given quantity times conversion factor 1 times conversion factor 2 times conversion factor 3. And also let's look at the units. So the first unit is grams water, which means the first conversion must have grams water in the bottom, so that that grams water will cancel with this grams water. So let's see how we can arrange this problem. So here we have our given quantity times conversion factor 1, conversion factor 2, and conversion factor 3. So we start with 24.8 grams of water. That is our given quantity. So to cancel these units, you need to use grams water down here. So you see that grams water here is going to cancel with grams water here. So we are saying we are moving from the mass of water, that is from grams of water, to moles of water. So if you have grams of water down here, you need to have moles of water up here. But once you have moles of water up here, know that you need to find a unit that is going to cancel these moles of water here. And what is that unit? It means down here you are going to have moles of water. So what's going to happen is this is going to cancel with this. But we are changing from the moles of the product, in this case the moles of water, to the moles of the reactant. And our reactant is the octane. So having moles of water here, to change it to the moles of reactant, we need to put the moles of octane up here. But once you put the moles of octane here, you also need to put the moles of octane down here, so that these two are going to cancel. So you make sure that in the end all the other units have cancelled. The only unit that we are remaining with is the unit that is going to give us our answer. That is the grams of octane. And that is the unit that we are going to have here, because this unit has not cancelled. Now, what numbers should we put here? Here, this is the molar mass of water. The molar mass of water is given as grams per mole. So the grams here for the molar mass of water is 18.02. So we put 1 mole here equals 18.02 down here. What about here? So for the moles here, we need to come back and look here. The octane, there is 2 octane based on this equation. So you can put a 2 here. There is 18 water based on this equation. You can put 18 here. But in the end, 2 and 18 will cancel each other. We'll have 1 here and 9 here. What about here? This is the molar mass of octane. So we always have 1. When we deal with molar masses, we always have 1 as a mole, and here we have the grams of octane. After everything, this is going to give us our answer here. So let's see what is the answer. So we're coming back to how we move from mass of the product to the mass of the reactant, and see how we use our conversion factors. So here we say every 1 mole of water has 18.02 grams of water. Here we are coming back here. It means every 1 mole of octane is going to react with 9 moles of water, which is similar to every 2 moles of octane is going to react with 18 moles of water. Here, this is the molar mass of octane. So the molar mass of octane tells us that 1 mole of octane is equal to 114.23 grams of octane. And when everything cancels, this will be our answer, 17.5 grams of octane. And let's take note of the significant figures. Here we have 3 significant figures because our given quantity here also has 3 significant figures. So that's how we use conversion factors to determine mass of one species when given the mass of the other species in a chemical reaction. And another important thing is to look at these coefficients. These coefficients are important because they help us to determine the numbers that we put when we are changing from mole of one substance to the mole of another substance. So this is the only place that they are needed when changing from moles of one substance to moles of another substance, because we use the ratios of the 2 species. Thank you.